This video will review an automated demo for the Keithley DAQ6510 data acquisition unit. The only required materials are the DAQ6510 itself, the 7700 demo card, commonly just called the demo card, and a USB drive preloaded with the demo script. The script itself is written in TSP, or Test Script Processor, and allows the instrument to function entirely by itself without any external controlling computer. TSP allows for much faster test execution and is exclusive to Keithley instruments. Ask your applications engineer to find out more. The demo card connections we'll be using are 4 thermocouples connected to channels 101, 110, 115, and 120. The thermocouple on channel 110 hangs outside the back of the switch card, so you can grab it if you want to see the temperature change over time. Now let's see what the script actually does. This is what you'll see as soon as you turn the DAQ6510 on. You'll see I select the script from the drop-down at the top of the screen and select OK. After that, the script starts. The script will handle triggering and moving between displays all by itself, so you don't need to interact with the instrument, but you still can, like I'm going to do. The first stop is channel settings. This is where you'll configure all the settings for the instrument function you've selected, overall scan settings, as well as any custom trigger events you'd like to set for the scan. Next up is the channel statistics swipe screen. This exists right on the home screen, and you can normally swipe over to it with your finger. The script will take you right there, though. You can see some key statistics for one of your watch channels at a time and alter between them with the arrows right there. The screen also gives you a large clear active buffer button for helpful debugging. Notice the icons in the upper right alternating between run and wait. Those icons are showing you where in the trigger model you are at any given time. For a simple trigger model like this, it's not terribly complex, but those can be very helpful for debugging later on. Next up is the reading table. You can normally access this screen by going through the main menu of the DAQ. Here you can see each individual data point you're collecting. Notice too that we've named each channel that we're writing data to. You can do that from remote commands or from a script itself. You can also drag along the spark line at the top that's continuously updated with your data. Finally, there's a smaller menu over here that allows you to filter out data that you want to see specifically. If we were writing to multiple buffers with this script, or from a remote interface, we could also swap between those buffers to view all the data in them as we like without interrupting anything. Another useful way to visualize data is the Histogram View. Here you can view all the data of an individual channel in bar charts. You can swap between individual watch channels using the arrows on the bottom there. Notice that the name we've given each channel shows up rather than the simple channel number. If I want to see data a little bit more closely, I can also zoom in and then auto-scale back out. Notice too the statistics that I get for each watch channel at the bottom of the screen. Since these thermocouples aren't hooked up to anything, I'm expecting something like a Gaussian. If you wanted to change the number of bins for this histogram, you could use the Scale tab at the top there. The DAQ6510 also allows you to set upper and lower bounds for readings you'd like to be aware of. So if I grab the thermocouple that's sticking out of the back of the demo card, I'll raise its temperature and you'll see an over-high warning pop up on the ASIC channel, which is the name we gave to channel 110. You'll also notice that this screen we're seeing right now is the scan swipe screen. It's actually the screen that's shown when you first turn on the instrument. It shows a convenient progress view of your scan and also highlights any limits that have been broken. When the scan completes, you have the ability to edit the scan that just completed or save all the data to a USB. Graphing is of course one of the best features of the DAQ6510 with its great full-color touchscreen. You can graph data right on the home screen of the instrument just by swiping to the far right, where you'll see whatever graph you've configured on the main graph screen that looks like this. Here you can see statistics for each individual watch channel and also use multi-touch gestures to better see your data. Besides simple graphing tools though, the DAQ6510 has some more advanced graphing features that you may be more accustomed to seeing on something like an oscilloscope. Swiping over on the bottom of the graph screen allows you to place cursors on the graph and calculate statistics of data between those cursors. This allows for much more detailed analysis of your data right on the front panel of the instrument without having to go to any external computer or software. For example, just by swiping over, I can see that the peak-to-peak temperature swing when I grabbed that thermocouple was a little over 7 degrees Celsius. Another great feature of the graph screen to check out is the Trigger tab, where you can define visual triggering on your data. Finally, the automated script ends and leaves you on the text swipe screen. From here, you can go and review any of the features already shown, or move on and dive into some of the other great features of the DAQ6510. I hope this automated demo has been helpful. For more information, visit tech.com/DAQ6510.